Hey there friends, I'm Leo, and I've got a question for you. Have you ever struggled to make AI for your game? And not just programming the character to move here or move there, but the actual AI design itself. I'm sure that any developer can relate to having the fear of having a cheap, asset flippy looking AI on their games, like an enemy that is just running towards your character and spams an attack animation. But how do we get past this? How can you make the character's behavior feel realistic and dynamic? So, you can keep the player immersed in this being an actual living being. And that's what we'll be discussing today. I'll show you guys my journey into AI programming after working with the Unreal Engine for a couple of years, and then I'm going to give you tips on what I've learned so you don't make the same mistakes. So I think you guys remember this dude here, right? This is the very first mob I've done for Spark Mods. It's supposed to be this initial enemy that is scattered around the starting area, just as you would see with any other open world exploration crafting-ish games. My idea was to bring this boar back and have it spawning on the dragon biome with a reworked AI. I was going to completely rework the boar, but I actually really like this model and I think it is going to work great, at least for now. I don't know, I just feel like it would be a waste to not use this 3D model. And even though it does not have a very good skeleton structure for things like IK, it is definitely acceptable without any major reworks. So now that we have our character, let's talk about the AI. Over the years, I've done AI for multiple enemies, some of them from Spark Mods and some of them from other projects.
I'm a monster.
What I've learned is that if your AI only has the command to just move around aimlessly, and as soon as it sees a target or the player, it just starts charging at him, then it is not going to be fun or engaging to play against. You can definitely add a lot of cool particles or maybe do some delays on the animation where the character starts charging up the attack before actually attacking, but that would still be a little bit stale. If you want to make deep, immersive and fun AI, you will have to spend a considerable amount of time not only doing the programming but also thinking about what the AI should do. Also, I've said this in the past, but never use blueprints to guide your character's AI. It is not gonna work and it's going to turn out very confusing. So if you're afraid of behavior trees, they get a lot more friendlier after you get used to them, and you should use them. When remaking the boar's AI, I was going to keep it simple and have the boar be stunned after receiving each hit. Quickly after the change, I found out the game was extremely boring. Hitting a boar was the exact same as cutting down a tree. You just gotta click and wait. In contrast to that, I have a more engaging AI that I've done for the Fish Units Mark III, where it would break free from a stun and do a full combo against you. It was then that I decided to spend more time reworking on the AI for the boars, so they feel more natural and fun to play against. So let's quickly go over how behavior trees work. It is quite simple once you get used to it. If you're already an expert on behavior trees, you can skip ahead to the next chapter of this video. I'll have it on the player so you can quickly skip to that. Behavior trees could be seen as the brain of the AI, just a bunch of possible actions that execute in order of priority. You can split these actions into smaller tasks that you can then program yourself into this behavior tree. This system is very powerful and also very customizable. You can do anything you want here. We start at root, this node here. We can have 3 logical arrangements. Selectors, which execute anything below it until one of them succeeds. If it succeeds, then it starts over from scratch. Sequences, which are just like selectors but is going to stop executing if one of their child fails. And the simple parallels. I haven't used these much, but I think with this you can just execute things simultaneously. And then we have tasks that can be executed on these logical arrangements. And these tasks can either be the ones that come with Unreal Engine or you can make your own. Keep in mind as well that their order of execution is always from left to right. So the order you position these guys is going to influence how they get executed. You can take a closer look at this bubble here on top of the selector, and this little number indicates the order in which these will be executed. So to make your own task, just make a blueprint that is a child of BT task blueprint, and that's it. And remember that you gotta use the receive execute AI event, and when you're done you can use the finish execute with either true or false, so you can then signal to the behavior tree if you succeeded or not. Besides all of that, we also have decorators. Think of decorators like a wall with a mean looking guard. This guard needs to see your ID and will only let you pass if you have the required age or whatever. So it's a simple check that is only going to return true or false, and it is going to only let you execute the task or logical arrangement if true. You can have multiple decorators in one single node and their logic stacks. Decorators can also cancel anything to the right of it or themselves. or both if you want to. And the coolest thing is that you can make your own decorators just by making another class being a child of BT decorator blueprint base. And then you can just override the function perform condition check. Then GG, you can do any logic you want here. There is another thing that is very useful in behavior trees as well, and they are called blackboards. Think of this as an area where you can store variables. These variables can be integers, booleans, objects, but these blackboard values need to be packaged into abstract values. So let's say that you want to grab the player value from the blackboard. You need to make a variable of the type blackboard key selector inside your task or decorator. This is like a little package that you can send any blackboard variable. So if you make this variable public, you can easily refer back to this variable later on the tasks. Then inside of the decorator, you can either get or set this blackboard key selector as whatever variable type you want it to be. Of course, it needs to match, right? So if you have a blackboard key selector and you want to set it as a boolean, you need to have a blackboard key of type boolean. With this, we can keep values not only stored in between tasks, but also change them dynamically in the behavior tree. Now, I'm gonna give you guys a tip on something that really helped me out in all of this. Did you know that you can set a blackboard value from blueprints, like outside of the behavior tree? This leads us to our next point. Remember how I said you should never control your AI using regular blueprints or, actors or components on actors? Well, you should still use one as an intermediate. Think of it like the middleman between your character, or in this case the boar, and its brain. So for SparkMuts, what I've done is an actor component called enemy AI, which is responsible for a bunch of very important stuff, like starting up the behavior tree on the character, or setting the player variable if it gets in range of this perception component here, or maybe detect when this character is in the air, like being picked up by the player combo system, for example, or detecting if the character just got hit, then setting the blackboard values to react to that. And as you can see here, this component is used as the layer that changes blackboard values on the AI depending on what happens to this actor. And I find that this is the best way to make the code in a way where you can easily reuse it later, while also retaining very unique behaviors. Because I can then have all of the mobs in the game having this enemy AI component, and I just change the behavior tree it uses. It's just simple and very reusable. So now that we have all of that explained, let's go over my implementation for a wild boar AI. Keep in mind, I will probably make this even bigger in the future, and each enemy is also going to have a unique behavior tree, by the way. So the very base for this boar is quite simple. It is just going to set its movement speed to walking. It is going to then look for a nearby area and roam there. This I think looks pretty natural, just as an idle state. If the boar gets alerted by your presence, either by you making noise or getting into its field of view, the boar is then going to enter the alerted state. This was pretty much unchanged from previous iterations because I really like this idea where you can just run away and the boar is going to revert back to eating grass or something like that. Oh, and speaking of eating grass, that's another idea that would be very cool if the AI had some sort of custom animation while not in combat. But okay, if you run away, nothing happens, right? But if you stay or engage the boar in combat, it is going to enter this combat area here. During combat, there are a bunch of different options of actions the boar can take, and each one of these options has a different chance to be picked at random. The first one is a very basic attack, and the boar is just going to move towards you and execute a simple headbutt attack. I tried making the animation very telegraphed at the start, so you can easily dodge something like this. The second attack here is called a bull rush, or boar dash, and it is a little bit more involved. In this, the boar is going to move away from the player, execute this huff and puff sort of angry animation, and then it is going to start charging towards your direction. If you don't dodge this, you are going to be knocked back to the sides. And if you do dodge it and the boar hits its head on a wall or a tree or something like that, it is going to stop and be staggered for a little bit. Next up is a different sort of attack, and this time is this sort of combo with multiple attacks where the boar spins around and tries to hit you with its feet. In this, it is just going to rush you and execute that attack. And if you dodge to the sides, the boar is going to dynamically rotate towards you as well. And the fourth option is just to run away. This is only going to trigger if the player is near and depending on the percentage chance. When running away, the boar is going to target a further area than if just using the bull rush ability, for example. After running away, if you don't chase after the boar, it is going to exit combat because it will be very far away from you. And now outside of combat, with a higher priority, is an area called stagger. Stagger has a chance to trigger with every single hit this boar takes, and it is going to cancel any animation or task it is currently executing so that the boar makes this little stagger animation. And besides a full stagger, there's also some hit animations that are blended in only on the boar's head, just so we can give the player a visual feedback of the boar getting hit. And now above stagger, we have a thing I call air stagger. If you're doing an aerial combo on the enemy, you basically pick them up and hit them in the air, right? During this, the enemy should be stunned in the air, like these ones on God of War, for example. So if you do any action that makes the AI lift up from the ground, it is going to immediately enter the air stagger state. If the boar dies during this, it is also going to do a different death animation on the air. And remember, all of these Blackboard key values are being set from the enemy AI component on our middleman. And now speaking of death, the task that has the priority above everything else is the die section. Pretty self-explanatory, but if the boar has no health left, it is just going to enter this section and abort all of the other actions. It will then do this animation, play a little particle system, and then drop the boar's loot. And that's it. That's the boar full behavior tree. One thing I think you guys might have noticed is that sometimes the boar does not move on a straight line when repositioning. And when making the AI at first, I saw that even if we add a very cool reposition task and all of these cool different tasks with different behaviors, the boar would always just move in a straight line, and that is very, very boring. So I had this idea of drawing a dynamic spline, which is like a simple white line that interpolates from one location to another using a curve. And then, after drawing the dynamic spline, I'd have the boar move alongside the generated spline. This is something that took me quite a while to make because I wanted to keep this very pocketed, or very modular. And a good way to make it modular was just to add a spline component using the enemy AI component. The problem with having a child component inside of the actor is that whenever the enemy moves, the spline is going to move with it because it has a relative location, right? And after doing some changes on the parenting of the spline component, it actually worked, and it looks much more natural to see the enemy move and do these little curves. I don't really think this would be very efficient if it wasn't for the enemy AI component to glue this all together. So then again, our middleman. Another very big aspect of what makes an AI expressive and intuitive is the particle effects and sounds that compose its animations and tasks. With this, we can give very important feedback to the player. For example, here is the boar rush ability without any particles. And now here is the boar rush abilities with particles and sound. I think this would be considered polish, but it only works when we have all of the AI logic behind it, kind of as a base. It is always very, very hard to imagine what something would sound like, or what sort of particle effects should play with an individual animation. This generally takes a lot longer than you would expect, but it is just as important if you want to keep player immersion. So one thing that I noticed that is a very huge flaw with the voxel plugin, which I think it is not going to be fixed, is that foliage that spawns on it does not affect navmesh. Navmesh is a navigable area that is used by AI to move around obstacles, essentially. So on the trees, the rocks, the copper nodes, any foliage on the voxel world, it is never going to affect navigation. And this leads to very weird results on the boar movement, where it is going to try and enter trees or pass through some obstacles that it should be going around. The reason why I think it is never going to be fixed is because I looked around the Discord and the guy that is working on the plugin gave a not so promising answer about it. So my idea to work around this is to set up my own foliage spawning system around the player using instanced hierarchical static meshes. With that, I would also be able to code my own system to save the foliage when you close the game, since I don't even know if that is possible with the voxel plugin currently. And in all honesty, the less I rely on the voxel plugin, the better. If I have my own system in place, it is a lot better to debug and make it work for whatever I need. And with that, I think we established some very good techniques and hopefully hopefully you guys feel more comfortable with behavior trees as much as I do now. In the future, I'm gonna focus on spawning stuff on the map, and if you guys have access to the playtest, you will see that you will already have something made to spawn the boars on the map. If you don't have access, however, you can head over to the Discord server and grab a key there. Subscribe to the channel if you want to see my journey developing the game of my dreams, or if you just want to see some cool game dev stuff every now and then. I'm Leo, signing off.